Okie dokie. Here we go. So I think we are here. We are on chapter 6.5, or chapter 6, section 5, filtering folds. Okay. Filtered. It's an extremely flexible, can be used on most types of optics. It allows you to filter down the focused elements to a subset which match some provided predicate. Very cool. Signature tells us the fold doesn't change the type of the elements as they pass through, it simply drops elements from the fold if they don't match the predicate. So let's get some examples. Okay. Why is this complaining? There's nothing here. What is it complaining about? What is this complaining about? Oh yeah, that's a redundant bracket, sure. Anything else in here? I have no idea why it's complaining that there's an empty space at the bottom of this, but sure, whatever you say, Captain. Okay, so we are on R underscore apparently. So R underscore 1, 2, 3, 4, and we want to fold this list with, I think is what it stands for, and we'll fold it to focus on the elements of the list, and then we'll filtered them if they're even. Okay, cool. So another thing we need is like a REPL to work in so we can test our assumptions. And this should print something like 2, 4, I would guess. And then we can oops. Load, run underscore 4. Not surprising. Okay, let's move this back up. So that's like a pretty trivial one. So drop fruits with names shorter than 6 characters. Okay. Apple. Passion fruits. Have you ever had a passion fruit? There's nobody watching, but if you've never had a passion fruit, they're insanely good. Pomegranate? Is that how you spell pomegranate? Oh. Folded. Filter. We're gonna have to say greater than 6 dot length, I guess. Right, so we take the string, we compute its length, and feed that to section. Oh, not filter, filtered. There we go. That should be fine. Okay, so that's just a simple mistake. All right, and then we already have seen the answer, but this should return passion fruit and pomegranates. Double check by running this underscore, and certainly get. Wonderful. Continue. Okay, so great. That's the idea. Pretty straightforward, I would say. Doing some spring cleaning, some favorite legally ambiguous trading cards. That's funny. There's a lot in the box though. I really hate reading. So in order to organize the collection, I'll need some folds to help me out. Careful not to fold any of my cards though. That would ruin the resale value. Sometimes I wonder if I should invest more into actual cards because they hold their value better than money. And we're gonna have to probably do name card. Aura. Hollow. Cool. Holographic. Want to be more specific? Moves. Move. Data. Aura. Wet. Hot. Spark. Leafy. An interesting aura. Arriving. Show. It's pretty amazing how unbothered I am switching between Haskell and PureScript. I absolutely love that. Like, it just doesn't, you know, it doesn't bother me. So move name string move power int. Probably gonna need arriving. Potentially. Excuse me. It's me again. Hello, viewer. How's it going? We're learning about filtering and folds. So we need to make lenses for card. And we need to make lenses for move. Whoops, move. Right, so that will take some of the template Haskell and take care of them. So what is this complaining about? It's literally right there. Please work. Maybe I can't put this here. I mean, I should be able to put this here. Data move. There. Let's restart and save again and see if that fixes it. I don't understand what it's complaining about. This file has gotten quite large. Did I not save? Like, I've saved this multiple times. What are you talking about? Is there some... Am I missing something? Aura. Move. Do these need to be above? Oh, yeah, they do. I think, right, the order matters with lenses. Sorry, that's my fault. So typically the order does not matter in Haskell code. However, when you do template Haskell, the order does matter. So we need to first define our data types before we can use them in the lenses. So this error is really complaining about not being able to make lenses when it tries to make, well, sorry, not be able to make lenses when it tries to make the lenses, not surprisingly. So this should now compile. Great. Okay, sorry, that's a detail that I forgot about a little bit, but we got it figured out. Okay. Okay, so we've collected some gosh, this is obnoxious. I don't know how you fix this. But when we copy and paste this in, it's going to be miserable. Oh, Have I not noticed that he's put gists into here before? Because that's unfortunate. Hello? Please go to gist. Copy link. Open link. Are you opening the link and I just don't see it? You're not opening the link. Okay, that's fine. It's up here, off screen. Sorry if you can't see it. Well, wrong keystroke, more accurately. There we go. Okay. So now we have our deck with a bunch of made up cards that I suppose are supposed to be like Pokemon. But I don't know. All right, so now we can start asking questions. ST underscore. So length of is a lens. Folded dot aura. So it's actually aura card dot filtered equal spark. Oh, spark deck. Okay, so let's put 512. So, all right, so we focus on the elements, which are cards. We focus on the auras, and then we filter them for spark. That's what we do. So close. Hey, I've decided to call you iodine, correct? Although I'm sure that's actually not how you want to pronounce it, but that's fine. How are you? Happy to have you. I saw you in the Soding chat earlier, which was kind of an interesting stream for him. Okay, so this is like how many spark cards are in the deck? Question mark. So folded moves is just moves. Okay, so we're gonna focus on all the elements of the moves, and then we're going to so let me kind of graphically show what's going on. First we focus on all the cards, so I'm just gonna click here, and then we focus on all the moves. Nice. Why are you compiling the Rust compiler? Isn't that one that you would just install? Or are you just doing that for interesting? But whole day relaxing sounds really nice. I coded Python all day, and I had to write a bunch of tests that like aren't Python tests. They're kind of like in Bash. So I was using bats most of the day, which was kind of interesting. But you know, I got the things tested I needed to get tested. Okay, so anyway, pretty much just for fun. Fair enough. Are you learning Rust or do you know Rust? Okay, so yeah, we focus on the moves, which is like the list. That's this whole thing. Then we focus on the elements of that list. And then we focus on the power, which is the second integer. So now we have all the powers, and then we can filter them for powerful cards. So move power dot filtered greater than 30. And then we just grab our little deck. Like so. So how many powerful cards do I own? Question mark. Something like this. I guess that's what we can call it. And then we should just double check this works. So we have 5. So we need greater than 30. So we have Explode, Gary's move, Capsaicious, something like that. I don't know. And then I guess Shock and Battery. That's kind of interesting. They're brilliant, right? Allergize. There's some pretty straightforward ones, like Squirtle, right? Scorchander are very clearly Pokemon. Electude. Capichu is kind of funny. They're pretty great names, actually. Some of the best part about this book is just the names and examples he's chosen. Also, how's it going, Chexer? Gary is represented. Is this like which Gary is this supposed to be? Or is this like a character in Pokemon that I don't remember? Okay. It's been a long time since I've done that. So I can't remember when I had Pokemon Blue, but I know I had Pokemon Blue at one point and a Game Boy but I don't remember Gary, unfortunately. I suppose we could look it up. But like the Spiceon's pretty fun. Gary, the Pure Script maintainer. I was thinking originally that these were like supposed to be Magic the Gathering cards, and for whatever reason that's still in my head. So I was thinking it's like Gary as in the Black Merchant of Asphodel or whatever he's called. If you know that Gary. Yeah, I think you know who that Gary is. Yeah. That's what he's called, right? Gray Merchant. Well, let's look it up now. Gary Pokemon. Gary Oak. There you go. Pokemon Research. Grandson of Professor Oak. Okay, interesting. Yeah, I guess it's this Gary. And then I was thinking of Gray Merchant of Asphodel. I think that's how you spell it. It's close. But this character is just, oops. This character is just referred to as Gary. Right here. Anyway, it's interesting. Okay, cool. So now we found some powerful cards. We found how many spark cards we have. And what do we want to do next? We can even use other fold queries inside our filter. Okay. This lets us filter elements based on a query over the currently focused piece of state. That's cool. I guess that makes sense though, right? V deck folded. Okay, so again, I'm gonna point out what we're focusing on. So we've folded, so that gets us to focus on each of the cards. And then we're going to filtered any of, okay, moves. So we're gonna focus on the moves, but we need to we're focusing on the list that contains the moves. And then when we do folded, we're focusing on the moves themselves. And then we're gonna focus on the move power. And we want to find greater than 40. Okay. And then we want to get the name, which is, I think, just card name is what I've called it. Or a card. Name card, the other way. Name card. And it's because I've used name previously. I kind of made one really long file. As you can see, there's like 600, almost 600 lines, 550. But anyway, okay, so I think this should print what? So we're gonna get greater than 40. So there's only 2 of them. Explode which is elect dude, and battery, which is Sparkion. Sparkion. Yep. Okay, so it does kind of what we expect. So we're filtering with an additional lens and then focusing again. Or how do we say that? We have a filtered that recurses further into the current focus, which is card, and then gets any of the cases where this is true, basically. And then we focus slightly further onto the name of the card, which is just this. Cool. Makes sense to me. I feel like some of the folded stuff is actually starting to make sense now, so that's really good. We can filter based on certain properties and then continue diving deeper into a different portion of the data. Okay. Length of folded. Okay, focus on the cards. Filtered. Dot. We're using the actual aura, not. Okay, I gotta think about this one a little bit. Folded. All right, so let me make this bigger. Okay, so we focus on the cards and we filter out their types. We're looking for the types that are spark. And then we continue looking for. Wait, what's the or? Oh, wait, what? Oh, right. Okay, we grab the aura and then check if it's equal to spark. That's what we're doing there. And then with those, we continue looking for the moves. So we do moves, which focuses on the list. Then we focus on the actual moves with folded. And then we just print those out. Cool. All right, so yeah, this was almost a little tricky at first because I was expecting to see aura card the lens there, and it's not there. If you're using stack for your project, you'll likely need to be on the nightly. Okay, we need to make sure our lens is of the right. We'll just close that. Stack YAML, not here. Packages YAML, and our lens 23 needs to be greater or equal to 418.0. Stack build. Okay, it looks like we're already on a newer lens than that. Should be good. So I think I can just freely reload in here and it should be fine. And then up here, we just go back into here. Okay, we're back. Okay, so we got filtered by. Laughably complex real type. It's a pretty hard type to read for sure. But it basically takes a fold of A, returns a simple fold. Yeah, still looks a bit strange, though not as bad as the real signature. You can see that it accepts a fold from S to A, but doesn't actually use the A for anything. This is because filtered by run. Oh, okay, that makes sense. So we filter by the current lens, And then instead of returning the A, we just return back the S so that we can actually do our filter. So it's probably something like filtered by, and then just aura card. I'm trying to think about it. So this takes, okay, so filtered by aura card, filtered equal spark, maybe? We need like a different syntax, it looks like. So filtered by aura card only spark. Interesting. And then we can moves folded by, and then we can filtered by a second time. Move power. Oh, here we would use filtered. I see. Okay, I was trying to use it in there. Filtered equals spark. That should compile. Move power. Filtered greater than 30. That's cool. So let's comment this out and instead place this with only, because we haven't seen only before. So we'll put that there. That's cool. Very neat. And we should see if it works, I suppose. Reload. So we just want to do deck this whole. Okay. Something like this, I suppose. It's gonna reformat this, I think. Yeah, that's better. Okay. So there we go. And then let's move this inward just as a reminder later. Cool. Oh, right. Oh, missing one part. Move name. So you can see we have a list here, but what we really want to do is focus in on the move name, which also means we need folded, I think. Hydrate. Got it. Oh, that's the wrong hand. Suppose it doesn't. Okay. Why is that not working? Wait, is this all we need? Filtered. Oh, I guess this means we've already focused on the moves. Right. Okay, so we've filtered them, and now all we need to do is go one further. Right. Okay, you got it. Notice how I switched it up. What do you think? Yeah, there we go. That makes sense. I was expecting I needed another folded there, but I actually don't, because I've already done the folded here. Alrighty. It isn't any shorter and can sometimes be more natural to express. We can continue to think in folds, which I suppose is important, because we're trying to think in folds. Yeah, we have this only thing. Excuse me. Okay, it accepts a reference value and returns a fold which yields a unit. Oh, okay. If and only if the input value is equal to the reference value. Okay, that's fine. So one, is this view? It's a flip view? These symbols are going to be hard to get used to. Import control lens. So structure. Yeah, I think it's just view. View. No, not quite. At least it doesn't look like it is. But also the types are a little funky, so it's got the same general shape, right? But this is a maybe. I guess that's the difference. I forget what this is called. Oh well. We can look at it later. Only one, which means it found it. Has only needle. Only. Okay. Here's one less complex example which uses queries when specifying the comparator to a maximum buy of. Oftentimes, committing to using optics means we can use expressions that read almost like English. Okay, cool, I guess. We're on to Y. Maximum buy of. We did not want that there. That's fine. Folded. Focus on the cards. Filtered. Why wouldn't we just... Oh, right, because that's a Boolean. So can we... Is there an... I don't know. Comparing length of moves. Back. Oh, right, this is holographic. So I suppose we could do... It's already a Boolean, so I suppose it just does what we need it to do. Just, it isn't a... You know, it's not as lensy as it could be. Maybe we can just do filtered by holographic. Maybe it needs to be only like that. No, it'd be holographic only true. Yeah, that would work. So it's a tiny bit more lensy, I suppose. Whether that's important or not, I don't know, but it makes me feel good that I applied what I learned. Okay, y underscore. So we get Sparkion and its moves, I guess. So what's the goal here? Get the holographic card which has the largest number of moves. Okay, cool. So that makes sense. All right, exercises, my favorite part. List all the cards whose name starts with S. Okay. So list all the cards. So deck. Focus on the cards. Filtered by name card not first, but take one only S. Well, okay, I mean I need to finish it. Well, no, that would be it, I guess, because you would just filter it and you should be done. Actual type. We take the deck, we focus on the cards, and we filter by the name. And if we take one, oh, maybe I have to do the other way. Only S. Hmm. Well, I think that we could just use filtered for this and might be easier. So like it would just be name card. Oh, it would be the other way. So um correct. Oh, right. Take one is probably not what I want. I want head. That's what I want. There we go. So I was just doing that wrong. Can we instead make this with filtered by name card head? I probably need Like, is this a thing? How do I... Isn't there like a first lens? I need a lens. That's what I mean. That's the key here, right? I just forget what it's called. First of. Well, but that returns a maybe, which is a problem. Oh, but we're using a filtered. So, is that okay? First one. Guess I want that. First one of. Oh, and the other thing I need to do is comment this out because it's going to be probably confused. So focus on the name, focus on the first one, and make sure it's only S. Would have guessed that this is right. Ah, I think I need first one of something else. Is it first one of all? Why is this traverse one? Both. Ooh, takes a long time. Oh, we can just do taking one. I'm just using the wrong lens. Let's try that. Taking one. No, taking one's not right either. I think that would take literally the first one, which is not what we want. What's the complement of both? All? I can't remember. Shoot. It's gotta be around here. Problem is I don't know what the type is, so it can be pretty tricky to figure that out. Something like both. Just don't remember the name. like every... I probably have used it, so I just need to like find it. Can I just use one each? So first one of each. I don't know how to do this with filtered by. Maybe he'll put it in there. It's hard to say. Okay. Anyway, I think that's right. So we can just check z underscore Squirtle. All the cards. Okay, cool. What's the lowest attack moves? So we're gonna say minimum buy of folded deck. Okay, so we focus on the card. Then we need to focus on the moves. Then we focus on the... Wait, what's the lowest attack power? Okay. We focus on the move power. And then we filtered I think that's it. Not a list though. Ah, I see. Okay, so we need something else here. Hey, Commander, what's going on? Comparing. For sure, no problem. Sounds fun. Sounds hard. I don't know much about ASM. Maximum buy up. Maybe I just need to do minimum of, and I don't really need to do this comparing thing. Maybe I can just do dot move power and be done with it. Yeah, I think so. Yeah, I know that feeling. Okay. So load just 3. Is that actually correct? Ooh, soggy. Gross. What's the name of the first card which has more than one move? Okay, so you can be off topic. That's fine. I don't mind if you're off topic. Do I know how Stream Fusion is implemented? No, not at all. I sort of know what it is, but I have no idea how it works. I think that talk by Alexis King would shed a little light on it, but I don't think she went into a ton of detail about like the how physically it's implemented. Like she explains kind of the why it works, but not the how it's implemented. If that makes sense. There's probably talks about that though that you could probably find. Excuse me. What's the name of the first card? Yeah, I don't know exactly how it works, but yes, it is interesting. Okay, so we need to get into our cards, but right. So now we want to go find filter by moves length of moves yeah, I would start with Google, but like I truthfully, I mean, a better place to do just or a better thing to do might be to just ask in the functional programming Slack or Discord or somewhere. Unfortunately, I don't. I'm not an expert by that. An expert. Filtered. Is this okay? No. I think we want filtered by. Filtered by. Kind of feel like I'm just iterating until it makes sense, which is unfortunate, but that's okay. Okay, let's look up here. So we probably just want to do it like this, actually. I think so we just want to go get the moves, and we want to know the length of them, and we want to know if they're greater than 1. That bracket's redundant. Okay, and then that should return all the moves with that. And then I think we can just do like that. Remember how to do this. If I get just the first. I guess it can just be first of. It can't. Maybe it's supposed to be E. Tech. We flip it on edge. Yeah. And then. Okay, so is that actually correct? Should it be Capichu? It should be Capichu. Nice. Okay. Are there any hot cards with a move with more than 30 power? Okay, so we want to probably do focus on the cards, and we want to filter the cards with more than 30 attack power. Greater than 30. We probably need filtered by here, don't we? So moves. Let's see what this does, I guess. Right. Yeah. Will this work? So filtered by. Moves. Move power. Guess And what's the aura card? Aura card only hot. I think. Okay, so now if we look at this, can I fix this one? Well, not fix, but can I make it first of folded, filtered by moves dot filtered greater than 1 dot length deck. Something like this, I think. So that seems fine. We'll make sure it's correct, but I think that's good. And then I think both of these are good. Okay, so we got B under gives you Kapachu. Then we get Kapachu. Great. And then C should give us apparently Spiceon, because this has a move power of 40. Are there any? Are there any is kind of an interesting way to be worded, but that's probably good enough. I suppose we could say like length of and then like compare it or something, but I'm not going to do that. Okay. List the names of all holographic cards with a wet aura. Okay, so deck folded, filtered by aura card only wet, filtered by holographic, and this can just be like this, I think. Okay, so so this needs to be dot only true, apparently. I'm expecting that to just evaluate for some reason, which is kind of interesting. So D double under. So cool. It's Gary. Hey, Gary. Okay. So D deck. No. Sum of deck. Focus on the cards. Focus on the moves. Filtered by move power. Filtered not equal. Oh, right. So folded, filtered by aura card filter then moves, then folded, then move power, something like this. I wasn't expecting that to work. .303. I don't know if that's actually true, but we'll find out. I think it's right. Yeah, they derive eq, so it should be good there. F. Oh, we're done. Okay, so let's go look at Chris's implementations and see where we're at. Time is it? All right, so we have some code written. Let's see what Chris has written, and then we'll go from there. So we got deck, folded, filtered, equal s. Okay, that's fine. So here we just use name card, but you know, functionally I think these are exactly the same. Oh no, they're not the same, because this is printing the names, whereas I'm printing the cards. Reload, see, I think I'm printing the cards. We wanted to print the names. List all of the cards. Yeah, I mean, I guess it depends what you're trying to do, right? If you want to list all the cards, then you list all the cards, but he's got all of the names. List all of the cards whose name starts with S. I think that arguably mine's correct. I don't know. Unless you interchange cards with their names. Hard to say. I like my solution. We're going to leave it. What's the lowest attack power of all moves? So minimum of folded moves, folded, move power, deck, easy. For this one, we did 2. We did... What's the name of the first card which has more than one move? So deck... Oh, this must be like a first of thing. Oh, right. We did just see that. We just used literally first of. So folded, filtered, greater than 1 length moves. Name. What's the name? Okay, so yeah. In this particular case, we do need dot name. And here we also need dot name card. Because yeah, technically what we were doing was incorrect. Well, there's nothing technical about it. What we were doing was incorrect. Because it's what's the name. Okay, next one. I was very close though. Like I could have figured that one out. It's just I misinterpreted the question. Are there any? Okay, so this should be a true or false. Oh, right. Okay, so we can just switch this to any of do deck. Like so. That should compile. Oh, apparently any of doesn't filter like this. I see. just weirdly sharp. All right, so we got to put greater than 30, and then we're gonna say we're gonna filter them by whether they're hot or not, and then we need to focus in on the moves, folded, move, power. I think. Methinks. Yep, that's correct. Okay. List all of the holographics with a wet aura. Right, so we used filtered by, which is fine, and we used filtered by a second time. Yeah. Yep. So like, again, we were trying to be more lensy, so I kind of like this, but you know, it's kind of unnecessary and arguably harder to read. Although maybe not. Only true holographic. I don't know. Okay, so we got folded. We're using filtered by a lot because I just want to. Filtered not equals leafy. Moves, folded, move power, deck, 303, done. Cool, so we did it. And we did have some issues, but it was mostly just because I misinterpreted this one, I think. Right? And the other one I was just wrong. I just read it wrong. But I feel like this could probably use a tiny, like, you could just say list all the card names. All the card names whose name starts with S. I think that is like a tiny thing, but would increase readability from my standpoint. Okay, cool. So now we continue on. Fold laws. And this is going to be 6.6. Okay. I figured I should probably have the section for consistency, but the fact is folds don't have any laws. Unlike lenses, we can't write set, get set, or set laws, since we can't set at all. This one's a freebie. There's no wrong way to query a data structure, so go hog wild and try out whatever you like. Nice. Okay. So there are no laws. Okay, so that's chapter 6, folks. We did it. So we will go. Interesting. Why would I want that? Whatever. Find. What's the other one? Brittany is the one I'm using. How's this one work again? Okay. I think we can do encountered XCPP aborting. Oh, I guess there's really only a few of them, so we. So what did it change? Set up Haskell? Why would it mess with Cabal? Did I make a change to Cabal? Yes, I did. Okay, that's fine. So I think this is okay. Let's look at this real quick. What did it do with like this stuff at the end? This looks fine. Yeah, I like it. If I recall correctly, it doesn't order these. Yeah, you can see like it's not ordered by alphabetically, but you know, it is what it is. We could do that on our own if we really wanted to. Okay. Add dot commit finish chapter 6 smile. Stack new chapter 7. Chapter 7. So what do we need? We need these jammers potentially. I think that's it. Stack build. Why is it building stuff? Oh, I probably have a new LTS. That's probably what's going on. We'll just use whatever LTS it gives us. I don't care. Assuming it doesn't take forever. We'll see. So how you doing, chat? Tell me your story. Compiling semi-groupoids. Lenses are fun. I'm having a good time. Oh boy. Lenses are wild. Yes, they are. I don't know how much of the filtered stuff you were watching, but you can do a lot of really cool stuff for sure. I think the biggest thing for me right now is just like remembering all the names. There's a lot of names. My goodness. Filtered by any of all of, you know, there's just a lot of names. I feel like I understand folding pretty well now though, which is good. I mean, not all of the operators, but I've looked at definitely a few of them. I mean, like we were just looking at first of, for example, and I'm pretty sure I know set and get. I would have to look them up at this point though, because it's been a few weeks since I looked at them. But I probably could recognize them in other people's code now. Like if I was looking at their operators, it might be obvious what they're trying to do and their types. But how are you, Tolt? I feel like I haven't seen you in a while, but you know, you could easily be just lurking. Yeah, there's some pretty wild ones for sure. And there's like there is a semantic meaning to those. Well, thank you for lurking. But yeah, I mean you don't have to always be part of chat. That's totally fine. If you're just hanging out, I appreciate it. Yeah, like for those ones specifically, I don't even know if you like just made that up or if that's actually a combinator. You know, it's hard to tell. Like, it's a pretty wild thing. All right, so let's see if we can figure out what this does. Yeah, I don't even know. We haven't done indexed lenses as far as I know, or traversals for that matter. Just the target of an indexed lens. given an index, an A, and a B. That would be funny. You should just make you should just make a quiz in general. That could be fun. Like, you know, how many of these can you get right without looking it up? That would be an enjoyable little quiz. Maybe we should make that on stream. That could be fun. Okay. What am I gonna do? I lost my train of thought. That's not your fault. I'm just, you know, just stating. We might need something from here. Right, we're gonna need, you know, these things probably. We're at least gonna need template Haskell. So let's just include template Haskell for now. We'll get rid of this nonsense. We'll get rid of this nonsense. And then we need to go into main and move this. Put Sterling chapter 7. Okay. And we're clearly going to need, I mean, I don't know what we're going to need yet, but we're going to need at least this. Oh, right. One issue is that our LTS or our LTS is actually too new. So I do need to back off of our stack YAML. Whoops. So that the versions match. So I can do 15, 14, but I can't do 16 yet. Otherwise, my IDE doesn't work. IDE, the Haskell IDE engine won't work. It should be clear. All right, so now we should have like autocomplete and stuff, which is good. Okay, I don't want to look at that right now. What I want to do is do this, and then we will talk about traversals. So, 7.1, introduction to traversal. Okay. Traversals are my personal favorite. They're among the most adaptable and useful of all the optics. I assume if they're anything like traverse, they're very powerful because traverse is very powerful. Traversals expand on the capabilities offered by fold, allowing all the same querying, but with the added bonus that we can update or set the values we focus in place. We can chain traversals to isolate and update to only a very specific nested subset of our data. Very useful. Traversals get their name from the traversable type class and corresponding traverse function. So we're going to see a lot of similarities. Traversals can perform pure updates, but can also run effectful update operations just like traverse can. That seems amazing. I'm also glad we spent a ton of time on folds because I think this part's just going to get, you know, more and more. It's going to become more and more I don't know, intuitive, I guess, of how to do all this stuff. Okay. So, how do traversals fit into the hierarchy? So we're going to combine all the power of folds and lenses together. Folds can get, okay. So it allows us to get or set 0 or more values. Multi-lenses. Okay. So lens, get, set, or traverse single things with a lens, traversal many, and with a fold we can only get things. Sure, this makes sense. That all lenses are valid traversals, but the reverse isn't true. All lenses are traversals, but the reverse isn't true. I guess I should write this as like, whoops, that's not what I wanted to do. I must hit caps locks. Like a quote. I like that. That's useful. I want to write that down. Does that mean traversals are somehow better than lenses? Nope. Sure. With the added generality, we lose some guarantees. When working with traversals rather than lenses, we can no longer guarantee that our optic must have a focus, meaning we need to use the more conservative viewing actions. I think that's first of or fold list with rather than view. Okay, I guess this makes sense. It's like view, but it's optional. And then this is view list with, I don't know why a dot dot is that way. And then this is just straight up view. Maybe this is like a maybe view, not a first. That might be the trick. In general, we need to be more careful using a traversal because it may fail. Here's a quick outline of which of our optics are valid substitutions for each other. The row labels represent what you have. The column headers represent how you use it. So how you'd like to use it. If you have a lens, you can use it as a lens, or a traversal, or a fold. If you have a traversal, you cannot use it as a lens. You can use it as a traversal or a fold. And a fold can only be used as a fold. Now, is this helpful? I'm not sure. Okay. So as I alluded to earlier, a few of these folds have secretly been traversals. Okay. So all of these are valid traversals. Neat. Okay. So from fold to traversal. Let's revisit both now that we can use its full power. Both is a traversal which focuses both sides of a tuple. Okay. The tuples generally. Pre and post structures. And be, yep. Yeah, I remember this part, so that's good. Took me a while to understand it actually, but I do now, I think. Okay, but now we've unlocked the power of traversals. We can also modify the focuses using the over action. Okay, so now we have traversals and who knows, Bubbles and Buttercup. What's the third one's name? Bubbles, Buttercup, and what's the third one's name? Powder Puff Girls? That's what it is, right? Powerpuff Powder. I'm an idiot. Characters. Bubbles, Blossom. Okay, and then we're gonna say instead of both, we want well, okay, let's just leave this alone because I'm not actually sure. I also forget what this does. Over. Okay. Oh, that's not what I want to do. VD7. A. Okay. So let's look at this type. Oh, okay, this is just why is it written this way? Couldn't we just stick it over here? Or can we not? Maybe we can't. But this behaves like the sharp from PureScript that we were using. Okay, sure. We can also use set. Dot tilde. There's the third one. Okay. Set both elements to the value we specified without regard for their previous value. Okay. We learned about polymorphic lenses a while ago. Can we just change these to like a number? 0. That should be fine, right? Yeah, totally fine. What's up, Lumi? How are you? We made it to chapter 7. We are now talking about traversals, which is pretty cool. Looks like it's more or less what we've done already. So it's just like putting it all together. That's cool. With that viewer counter. What's wrong with the viewer counter? Does it say something strange to you? It says 2 to me. I don't know how many people are here. As far as I know, it's just you and Tolt, potentially. Also, my subscriber number seems to have gone up. Oh, that's why. Okay, that makes more sense. It was just slow. I just noticed it went from 6 to 7. Lumi, thank you so much for subscribing for 8 months. That's a crazy long time. And I really appreciate it. Oh, this is gonna fail because we need to change it to C. Okay. Seriously, appreciate it. It's also interesting that your little first badge just popped up for some reason. Like, I see Twitch Prime and then your little first thing. You see more than 2 in chat. Well, I see like only a few people. I don't know who's actually in chat. It's hard to tell, but the viewer count seems wrong, I guess. So this is pretty cool. So we can just like replace, if we wanted to get the length of both of these, we can just use lenses pretty powerfully to do that. Right, each. That's what I was looking for before. So you could do like bubbles, buttercup, blossom, and then each length. Nice. Noise. Okay, so sure, that makes total sense to me. Yep. Set to 22. Okay, so let's see. Regarding each specifically, whether it's polymorphic traversal depends on which structure you're using it on. Certain structures like lists and tuples can freely change types, but others like text or byte string are monomorphic structures. A text block must be made up of chars. We can't just change them to ints and expect it to work. Ah, okay. That makes sense, right? It seems it seems weird that somebody would try to do this, but you know, maybe it makes sense. If we did do it this way, Houston, we have a problem. Each dot 22, then we would just replace all the characters. But something like text, it doesn't work quite like that. And I guess anything that's not just a list, it's just a list, then we can just use this as we expect. That makes sense to me, I think. Okay. This is interesting. Taking 3 traversed over with times 10. Very cool. Okay, let's write that one down because those are strange. 1, 2, 3. Why am I writing it like that? Taking 3 traversed set with times 10. That's cool. E, F. That's pretty neat. It's interesting to me where traversed shows up here. Right? I was sort of expecting traverse to somehow come up in front. Okay, so taking while not equals reversed. Wait, maybe we probably need traversed. I'm not looking on purpose. Over to upper. Import data car. I'm just gonna import data car. I don't feel like figuring this out or dealing with the issues. Okay, so in theory that's right. Yeah, that's cool. Traversed to upper. Sure. Filtered can be used to filter focuses from a traversal. Each. Oh, you probably can't see this. Let me scroll this up a little bit. Sorry about that. 1, 5 traversed filtered even. So this is going to multiply the even numbers by 10, I take it. Very cool. These things are pretty wild. Okay. So short, longer. So we're gonna say both traversed. What are we gonna do? Okay. Filtered greater than 5. What did I do wrong? Both dot filtered dot length over reverse. What is this complaining about? I feel like I'm missing a traversed. Anyone see it? I don't see it. Maybe there's nothing actually wrong. Nope, definitely wrong. I don't think we would need traversed here because, like, this means, go through the entire list. But maybe we do? I don't think so. This is like the list operations need traversed. So we have both over length. What if we put this whole thing in parentheses? Does that change anything? I suppose it shouldn't. I don't understand. Okay, let's stare at the error for a little bit. Expected type. Actual. So its actual type. I see it. Extra character at the end there. Reversed is a lens, probably. Yeah. Yeah. Okay, anyway. Silly mistake, my bad. Okay. So 7.2 Reversal Combinators. Okay, so traversing each element of a container. In the chapter on folds, we learned about folded, which focuses each element of a foldable container. Folded is only for folding. If we try to set or update using folded, GHC will yell at us. It's not mad, it's just disappointed. That's funny. So I presume that this means that we need J1 at traversed Does this compile? It does. We could also change this probably to the following. So just multiply all the numbers by 10. No instance for contravariant. You have conflicting constraints like this. It's either because you're composing incompatible optics together because you're using an action which is incompatible with your optic. In this case, over action requires a setter and wants to use the identity type, but folded is a fold which requires a contravariant instance. The two can't get along. Okay. Traverse can focus on the values inside any traversable data structure. Requiring traversable as opposed to foldable gives us more power, but also reduces the number of containers we can operate on. Yep, that's surprising. Sets are foldable, but not traversable. Yeah, okay, it's fine. This is what we just did, so we fixed that, or fixed. We just changed. Batman. How's that go? That's not how it goes. I was just about to sing the chicken dance. Reversed over take 3. So this would take bat and sup, I suppose. Okay. Oh, okay. Right. Because we're not actually doing a both. We would need to change this, I guess, to not traversed, but both if we wanted to do what I just said. If we just use the traversable instance directly, it's only going to work on the second one, because if you try and traverse or use functor instance on a tuple, it will only operate on the second one. Okay. That makes sense. Yep, it says it right here, but I'm glad I just came to the realization without having to do that. This is funny. Power level 5. Okay. Import qualify data app. It's M. So power levels. Can you guys hear the sneezing? I don't know if it's loud enough or it comes through the. Clearly hasn't gone through his shapeshift or whatever it's called. I don't remember what the term is. 9001. This is very early on in Dragon Ball Z, by the way. Where's Vegeta? Am I right? Seriously? Piccolo, but no Vegeta? Rude. We're gonna put Vegeta in here. Vegeta. And he will be 1 less than Goku. Although that's probably inaccurate, right? He's very powerful, but he's not as powerful as Goku. And then Piccolo. Wait, isn't Piccolo more powerful? Well, I don't know. Again, I don't know what. I just realized that these are all strings. Oh, I see. We're gonna convert them to strings at some point. I would have guessed. I mean, I don't remember when these numbers were valid, but I would have guessed that Piccolo is stronger than Gohan to start. When we're talking about like 9,000. I feel like it was much higher than this before. Okay, so we could write something like L power levels traversed. So that means we're going to get each of these, and then we can say over. So we're going to have N. Oh, right, because we're going to traverse over the right side. So show N. Sure. L. Oh, interesting. This is also like a map. I like, for whatever reason, that didn't click to me right away. So we've mapped over the values of the map. That's cool. I was thinking that these were just like tuples, but this is actually a from list. So a list of tuples, rather. So that's a little bit different. Okay. We can even traverse over more complex structures like trees. Ah, I'm very, like, my nose is very itchy. Import data tree. Optics tree node lens node hold node reversal it's interesting to me that these go over the traversal instances over the string, but let's look at this. So import data tree info tree root label. Oh, okay. So we have the root label, which must be okay. That makes sense. Yeah, because this is forest A, so it would be like you would have to traverse and traverse a second time, I suppose. Something like that. Let's see if we can make that work. So hello. Oh, this won't compile though, will it? Because it's got to be a forest. So what's a forest? Is it just a list? It's a list of tree. Okay. Ah, I see. So actually, right. So this has to be like this. So this makes sense, actually. I'm being stupid, I think. We're only ever going to have the keys and then, like, empty lists. So, yeah, I'm just dumb. Or not the keys. We're only going to have the nodes. What are they called? Why is my terminology completely ruined? Leaves. There we go. Okay. Leaves, plural. Okay. M seems to work. Very cool. We might even want to like focus on the nodes, but I'm not actually sure how I would do that. Guess I could just do folded, maybe? I'm not sure. We'll play with this. Okay, so let's tack on a few more fun traversals before the exercises. Subsections of strings. So actually we used this before. We used worded before. Should operate over every node, not just the leaves. Well, aren't these just leaves? And then you have just subforests. Is that not what the right term is for this? I mean, all of them, obviously. I'm probably just using the wrong term. Ah, okay, so this thing here is a leaf, and this piece here is like a branch. I see what you mean. Yeah. That makes more sense. I understand what you mean now. The leaves are just the ends of the branches, or the ends of the subforest. Sure. That's fair. That is fair. Okay, lined. I don't know what lined means. Oh, lines. Okay, that makes sense. So we could do N be back. Worded. Can we do something like this? Worded, traversed. I'm just trying to think out loud. Oh, right. Wait. Yeah, this is over. We want this, I think. Thank you for that. Maybe we don't even need this. Maybe we just need worded. Oh, I think we need to get rid of this. I think this is supposed to just be... Maybe we needed folded there? No, that won't work. So this should work. Maybe I need to put a dot in there. Doesn't work. I'm confused. This makes a list of things. And then we traverse them. Let's go look at a list example. Oh, maybe we need to do like... There we go. So this makes a list of the words, and then we can traverse them and set them to hello. So I suppose this would work. Okay, that makes more sense. Alternatively, we can write, well, let's just... at worded hello, I think. Yeah. No. Oh, right. These are actually different. Very good point. So because we're turning a list, we actually get a list of the words. In this case, or in the bottom case, we actually just directly set them. So hopefully we see the difference, but that's kind of interesting. maybe I should put like the actual evaluation in here just to show the difference because it's kind of cool. I don't know how this is useful offhand, but it's kind of interesting. Okay. So we gotta scroll back down, looking at combinators. So this one is just like a capitalization function. I actually think there's a function for this. I want to go look it up now. Bite, blue, suede, shoes. That's a song, right? Oh yeah, yeah. Like you, right? That's a good idea. So then you could do search and replace, or instead of worded. Well, okay, I could see how you'd use it here, right? You would just use toList of worded and then dot whatever the second one is. You can't use _2 because that doesn't do what you want it to do. How do we do that? How will we change just the second word? Kind of interested now. So we probably don't want to make a list. Probably just want to do worded. Oh, you know what? I think there's an indexed thing for this. So like there's a whole list of indexed functions that we don't know about yet. Interesting thing is the implementation of worded actually fmap unwords, conjoined traverse, indexing traverse. Huh. So maybe we can do indexing traverse. F. I don't think I can do this yet. We don't have the tools to do this yet. I like the bit in the middle is the part that's confusing. Conjoined traverse, indexing traverse, F, right? That's the part that's strange. So, I mean, I understand that it's just this, that's F, but it's a little strange, the conjoined traverse thing. Hopefully we'll learn about it. So we wanted to do worded over, and then we need to find the function that does capitalization. Oh yeah, forgot about this. Google capitalize. Is there no string to string function that does capitalization? I feel like there is. That's really not what we want. Data string. Maybe it's like in an extra. Yeah, that's a good point. But like in your example with the second, do the second one, we would need to figure that out. Maybe there is no capitalization function. I feel like I saw one before. Haskell capitalization function. Maybe there's like a string extra or something. I mean, I know how to do it with a lambda, obviously. So, but maybe it doesn't matter. Oh, right. Okay, so capitalize is a little different than what we're even trying to do, but mean, this is really scary type would go here. But this is basically what we could do. That's actually super cool though. But again, overkill. So what are we trying to do? We're just gonna say given S to upper X XS, I guess. And that should work as expected. Nice, cool. Prefix with a sharp. This makes sense. Here, you mean, or just here? Anyway, okay. Oh, okay, I see what you're saying. Like this, maybe. If we're using lens, we might as well use lens, right? That's the idea. I don't know if we've used the head lens before, but maybe we have. It would be, I think when we were doing the first of stuff before, it would have been easier. How does this behave on an empty list? Does it just do nothing? Or an empty string? I think it would just do, yeah, okay, right, because there's nothing to focus on, so it doesn't ever even use the over. Oh, wait, I didn't want to copy this one, I wanted to copy this one. Yeah, okay, it does the same thing. Not surprising, I suppose. But anyway. Okay, so we did that. Be wary that this is how worded and lined from lens behave. Even though they're not lawful, they're still useful. Okay. Traversing multiple paths at once. Okay, so that was basically what that person was doing with the composition of first and last, or the capitalization function. Okay, like most combinators, there are many possible signatures, and the actual signature is an absolute nightmare. Here are a few specialized ones which are a bit more approachable. So beside, so we have two traversals on a two starting structures and two ending structures, where we focus on A and convert those to B, I guess. Okay. The first thing we notice, this is a higher order optic. It takes two optics as arguments and returns a new optic as a result. Yep. These signatures are pretty confusing at first, but if you stare at them for long enough, you'll figure it out. I'd recommend you take some time to study them and make a guess about what it does before moving on. Learning to read these signatures for yourself is a pretty useful skill. Sure. So, I guess we could write something like no, we need to make two optics. So we could say this So that gives me, that would be like both, I guess. And then we could say like 1, 2, both over times 2. Makes sense. Well, the structure needs to be slightly different here, I guess. I thought that would be like both, but it's not. I think my intuition is correct here that somehow we need a tuple, but it's not clear to me. We need to convert A's to B's. Do I need to say specifically that these are ints? Does that? I don't think that would matter. Oh, maybe it does. No, it doesn't. Oh, wait, no, that's right. That's a times setter. Okay, let's just play with it. Why can't I spell? Okay. Ah, I see. I was very close with this. It's not 1, 2, it's just id. Right? Because it's combining two we're combining two lenses and we're gonna focus separately on both of them. Like once you see an example, it's pretty obvious, I guess. So we could do this, and then we could do something like could give the dinosaur names like a we keep doing this, but I don't want that. I want this. I don't need lists. What I want to do is change the names to like whatever. The Rawr. Wonder if there's a plus plus setter. Is this a thing? No, not a thing. Percent. Very cool. Very cool. Okay. Let's do our okay, so we got a tuple of lists of tuples. And so we're gonna say beside We want to focus on all. Oh, nice. Yeah. That would be better. That would work. Good call. Sweet. Very cool. Forgot about that. So we want to say folded dot both, and here we just want to say folded, and then we want to, I don't know, increment them by 1. Oh, we can't use full. We need traversed. Do we? Because we want to do set. So I think that this will return the original structure with everything incremented by 1. That's so cool. Again, I don't know why this would be useful yet, but you know, it's a thing. We could also do T, where we just like flatten this list beside so that would just flatten the list, which is cool. A weird flatten, but that's a flatten of some kind. Neat. In both? Yeah, we wanted to try that. Something like that. Can you see how beside is more powerful than both? Yes. Okay. And modify all characters inside both halves of the tuple. So beside, traversed, right? That makes sense. Could we do, well, no, because we want to get to each character and then just do 2 upper. Sure, that makes sense. Yeah. Besides works on any bitraversable type. That's useful. So either, very cool. That's neat. Comes after T. You. I'm getting tired. Oh, interesting. Right, because oh, right, because we're using both. That's the key here. I was like, wait, what? But yeah, besides both makes sense. So we're not. This is interesting to me because I would have guessed that this doesn't even matter. And it actually fails with this in there. Because there's no way for it to know. You would have to write you either int or something. Right? There's no way for it to know that these are the same things. I guess you could even probably write a and it could figure it out. No, it can't. Can you? Is it going to say something about? Oh, right. Okay, that makes sense. So anyway, we don't need to write this, but this will fail. So we should tell Chris about this because it's a little minor, but it's important. So what are we on? I think I downloaded the new one. So this is 134. And I suppose we can mention the other issue we had too. Like, it's minor, but I'll find it again. So page 124. List all card name. And then yeah, and this both is going to fail as well. So these will fail on the command line as well, right? If I write traversed here, or do they just like reversed? Oh, it just works on the command line. That's interesting. Why does that work? Why does that work on the command line but not in a GHC file? Or a GHC file. A Haskell file. That's kind of interesting. I'm not entirely sure why that is. Anyway, whatever. Right. 1, 2. Beside id reversed negate. It's kind of interesting. I suppose that if we... Oh, look at this. So here you have to write this. But here you don't. Will this just fail? It will, unless this will fail, I guess. But you need to write, if you write id here, it should be okay. Weird. That's pretty strange right there, honestly. That this is necessary, but this is not. Maybe it's because traversed is so general. And both is less general. Something like that. Well, what's the type of this? Okay, so it's like it can figure out that this is any traversable container that is also a num. It would have to be. That makes sense. It can't be f of b because we're using negate. Okay, here we go. So now we're going to say focusing on a specific traversal element. So I suppose we're going to combine this with some sort of filter. Oh, here's what we wanted before. So we'll focus on the second element and then change that. There's the thing we need. That's kind of funny that it comes up that quickly. W. So what we want to do is go back to this example and see if we can use this to make it work. So we're going to say element So it can be any traversable, which means we can use worded. And then what we want to do is say element dot element 2, no, 1 in this case, for second, not 0th, but first. And then change that to blue leather shoes. Dot for set. Worded maybe I need another ampersand. Worded. This is a simple traversal. Right, so this gives me the first of the element 2. It can't change the type of the container's elements. Oh, maybe I don't even need... No, because this will say, right, if we did element 1, then we would only be able to set a 1 character. This will work. But we want to do... Okay, but that's not quite... I don't really like this. I don't really like this, but, you know, it is what it is. Maybe there's... Ooh. Ooh. Element of. Element of. Could we do... element of worded 1 set leather. Oh, I'm doing set backwards, first of all. Did I do that before? I don't remember. Let me try again. So we wanted to do worded dot element 1. Oh, no, that fails. What if we do, instead of that, we just apply it? That probably won't work either. Okay, so we need element of there, which is fine, but that does what we want it to do, I take it. We need to change this back to W. There we go. Cool. So this is totally fine for these cases. Ooh, powerful. Cool. Okay, so we did that. We talked about it, and then we were able to do it, so that's fun. 7.3, traversal composition. I suppose we've kind of already have done that a little bit, so that's kind of cool. We can express complex transformations by composing multiple traversals. Each traversal selects focuses, then rebuilds the structure around the transform result. Taking one traversed. Yeah, we kind of did this. This is the same as head. So we actually wrote that before. Find all strings longer than 5 characters, then surround each word in that string. Okay. So traversed, filtered, worded, over. And here we could actually do a slight, a very, very slight performance update where you just do character : S plus plus star. I highly doubt it will actually matter, but Reggie Rich. I feel like this should go the other way. Because it's like, it's Richie Rich. Each. Okay, so we focus on any of these. We filter where second is greater than 1,000. We take the first and then append or prepend rich to them. Got it. Okay. There's really nothing that interesting to put in there, I don't think. I mean, it's just kind of like combining everything we know so that we can do over. What type of optic do you get when you compose a traversal with a fold? Of the optics. Okay, so which type of optic do you get when you compose a traversal with a fold? I guess you have to have a fold because you can't, I guess you can't escape from the fold. A fold. I think that's the answer. Which of the optics we've learned can act as traversal? A lens or a traversal, I think. A lens, fold, or reversal, I think. We'll look at the answers. Okay. 2. fill in the blank. Black Lives Matter. Okay, so WX. So this is just both. By the way, Jurassic Park is my favorite movie, if you want to know. Okay, so we want to go over both and then basically focus on each element. Folded. No, traversed. Because we want to change them. D. Okay, so we want to beside, because we want to right, id will give us this first one, and traverse will give us all of these, and then we will take the first three. I think that's right. So we're on to the primes. We did this one first, so now we want to do this one. Okay, and we want to end up with this. So focus on 2. I guess this is element 1. Okay. Okay, so first things first, we're traversing on the outer one. And then we want to do elements of, yep, I think it's just elements of traversed worded. How do we use elements of before? Element. There we go. It's just singular. So there must be an elements of as well. Usually says they're this one's tricky, but that one's not very hard, I don't think. But I also, we played around with elements of because we were thinking about that other example earlier. Okay, let's do this. C prime, and we want to get the following. Oop, I need to put. Okay, so we want 2, 3, 4, 5. So this is going to be. Can it be over? Isn't it both? It's not over. I always get this one wrong. Each. It's each. Each. I think. I want to check that one. The other ones I feel pretty confident about, but that one I wasn't sure of. Okay. So we got this wild one, and we want this. Now, one thing that I don't love here is that there's a single hole, and we filled it in with 2 things. I don't know if that matters. Now, does each do what I think it does? I think this will just fail, right? Yeah, that will fail because there's no way to add 1 to a tuple. So that I think this is right. Okay, so we want to do 2, 3. We want to do basically the same thing. So we can do beside id traversed. Noise. We could also probably do beside each. Nah, I think we need beside there. For Hots and Plots, what's up? How are you? Thank you for being part of the Soding Comrades. I am also part of the Soding Comrades. I like supporting him. Alexi's a pretty funny dude. Funnier than me, for sure. Okay, we're still going. So we're learning about lenses. I don't know how much you've done with lenses, but they're very fun. And they lead to some very interesting exercises. So we're kind of just working on the exercises. I'm going to finish up once we finish these, and then we'll check the answers, and then we'll move on. But, you're welcome to hang out, obviously. Although, what time is it for you? You're not actually following? I feel like I've seen you in here before, so thank you so much for following. Appreciate that. But yeah, maybe I haven't seen you on the stream before, but I've definitely seen you in Soding's stream, obviously. Wow, that's late. That's very late. It's 10 p.m. and I'm ready to go to bed. So, I hope you find sleep. Yeah, you guys are. I don't know how you do that, honestly. I have a hard time doing that now. Maybe you're younger than me, I don't know, but maybe you just don't sleep. Polyphasic. Oh, you do like sleep on and off kind of thing? Oh, I don't know if that's actually polyphasic or if that's like something I'm not familiar with, but I know there are some people who do like 4 hours of sleep, stay up, then sleep for another 4 hours. Is that what polyphasic is? 3 times over the day? Cool. Okay, so I kind of just made that up. Not made it up. I mean, I feel like I was familiar with it, but okay. So basically what we're doing right now is filling in puzzle pieces. So the idea is, I don't know how familiar you are with Haskell, so it's hard to say, but basically we start with this structure and then we end with some other structure. And what we need to do is apply, apply these to that thing. So in this case, we need to say each, because we want to go over all of these. And then we want to focus on the second element. And then we want to take the first 5. So it's going to be taking 5 traversed, I believe. And then in theory, that should convert these first 5 elements to, it's only for true, sorry. So we also need to filtered. Okay, so filtered 1 dot only true dot taking 5 traversed. Let's see here. Oh, I can't do only true here. We have to do equal true dot first, like this. It doesn't like each. Huh. I suppose. Oh, wait, no, because we're using ampersand. Why doesn't it like each? Yeah, like they're super powerful. Maybe I don't need this traversed here. Maybe it's just taking 5. No, I'm pretty sure I needed that traverse, but I'm confused at this each. They're amazingly powerful, which is, it's very, very fun to use them. So we can't use beside. I'm just trying to think of the tools we have in our toolbox. This seems right to me. That's very true. Oh, it's not dot. I think it's this. I'm so confused at this one. So we go over each of them. We filtered by their first, where it's equal to true. Maybe what if we do filtered by 1 dot only true? Does that, it does the same thing. This one's hard. Let's make sure I didn't make any mistakes here. I feel like this is right and this is right, but maybe it's not right. We want to focus on each of these. 1, 2, 3. Maybe. No, we can't use traversed because traversed will only do the second bit. I'm unsure. This seems like it should be right to me. Unfortunate. Let's comment this out, but I don't know the answer. It seems to me that that should be correct though. So we'll put f prime in here, and we need to get this. And we're gonna say the result is supposed to be this. And to me, this one is relatively, well, again, maybe it's not. It should just be each one. No, 2. It does not like this each at all, which is very interesting to me. I don't know why. I don't understand these. I'm probably doing something like very dumb. So how different is Hugs 98 from like sort of stack installed Haskell? I mean, like you don't get a lot of the libraries, right? I don't. I'm not used FreeBSD personally, but I know that things can be a little tricky over there, especially on the architecture you're using. Because why would it be easy? Let's go look at the answer and see if we can figure it out. I don't understand why each doesn't work there. If we have a tuple, we should be able to go over each of them. I don't understand. Filtered. Oh, I need a 2 here. Oh, and then if I want to use this, I need to write filtered by, I think. No, it still complains. Filtered. First. This is clearly one of the, oh, wait, I lied. Hang on. Okay, that fixes it. So filtered by, I want to see if this works. First dot only true. I see. Okay, so why is this one problematic then? So we do each 2 traversed. Am I supposed to have traversed here? I don't think so. That doesn't make any sense. The focus points are here. Do focus on 2. You get byte string base network, parsec, OpenGL, OpenAL. I don't. What is OpenAL? The audio thing. I actually don't know what OpenAL. X11 and a bit more. Reasons. You probably don't have applicative either, right? Well, I don't remember when applicative came in, but either you don't have applicative or you don't have applicative in the right place, right? It's not in the right hierarchy. Probably one or the other. I love applicative, so. I'm a little confused by this one, honestly. It's probably because I would need to do something like to list of, maybe. I don't know. I mean, this makes sense. Like if we just do second. So it's like over each of them, grab the second one. And actually that's probably the best way to do it. But I'm confused at why mine wouldn't work. But again, lenses are quite difficult. So it's hard to say. Probably used. It doesn't have applicative at all. Okay. And I suppose it's no longer maintained, which at least I don't think it's maintained, but I don't know. Probably used a traversable when you wanted a fold. It could be. The problem is I want to end up with a tuple, right? I really want to understand what's wrong with this. So we have each. Is it right on the front page? No longer in development. Unfortunate. Archived. Sad about it. Wasn't I don't know if it's Steven or Stefan Deal trying to also write another Haskell compiler, but more for like learning how to do it. So, right, we're focusing on 2. Let me see if we can find it. Steven Deal. Yeah. Oh, it might just be this. Yeah. Here. So it's working through writing your own version of Haskell, but it's only like partially done. As far as I know, it's dead, but like the idea is there, which is kind of cool. It would be neat if somebody took this over and did something with it, like, you know, just continued. I guess that's kind of what. Well, I think Hugs was around before that was around, but I have seen that before. It looks really interesting. I don't know how to do this other than this, I guess, but for whatever reason this is extremely unintuitive to me. Like it's not unintuitive in the sense that I don't understand what it's doing. It's unintuitive in the sense that I wouldn't have written it. K and R. I don't even know what that means. K and R, C. I know what C is, obviously. All it's trying to do is pick out the seconds. So just picking out the second elements. So you just say each over second, and then you just get those things. But for whatever reason, this is just not clicking in my head. I don't know why. Like why it's this and you can't do something else. Oh, okay. Yes, I've not coded long enough. No, you can't. So if we do each 2, I think what we have to do is like no, because if we do each 2, this is the lens. So then we could do something like this, right? So this is totally valid. And if we did this, it would be like, you know, we're doing that. But what we actually want to do is pull stuff out. We need to change the structure. And so to change the structure, we need an operator that changes the structure, which is over in this case. So I guess that's the trick. But I don't know why it's bothering my head. Although I guess it is in the sort of hard section. So maybe that's why it's bothering me. Okay, anyway, we're done with this. But I want to check our answers to make sure they're okay. All right, so there's probably another way, but I can't come up with it in my head. That's all. So we'll just quickly look at the answers and see what we do. So like for her hots and plots, if you've not seen like lenses, like here's an example. So basically we have this structure, and then we're going to feed it to this function. So what this says is for the tuple, focus on both the elements. So you're going to focus on this, and you're going to focus on this, and then set them to NA, and that's what happens. So yep, and that's exactly what they have. Chris is a specific person. For this one, we're going to change each one of these elements, so J, U, R, blah, 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 to X. So we say both because we want to focus on both of these, and then we want to focus on all the characters. So typically, if you wanted to focus on the characters and not change them, you would use folded. But to change them, you have to use this traversed, and then you can set to X. So that's exactly what it does. Perfect. That's interesting. We could have used each here. That's kind of cool. I wouldn't have thought of that. I like the traverse because I feel like I understand what it's doing. This one is interesting because it starts with a tuple, and what we want to do is change elements inside of the first and second element. And so what we do is we use this beside combinator, and it just takes like the identity, because the left side is just a list, and then the right side is a list of strings. Sorry, it's a list of characters, and then this is a list of character. So we use this traverse thing to focus on each one of these, and then basically we kind of have like a Malcolm, Kaylee, Inara, Jane list more or less to work with, and then we just take the first 3. So that's what over. This is over. It's like apply this function to what you're focusing on and returns this. So it's pretty sweet. And like you can do some really wild stuff in here. Like this one's pretty wild. So replace all the characters of the second word with X. You can do that totally fine. This one increments all of the numbers in a tuple of tuples by 1. Fun. I can't imagine he wrote this any differently. 2 element 1 river traversed element of worded 1 traversed. Nice. And then both dot both. Oh, I wrote each dot each. In this case, they're the same. The difference is each dot each would work if we had a triple of triples. And then we have this more complicated beside example, but it's basically taking this beside and embedding it in another beside. So like all kinds of weird stuff that you can do. So anyway, that's that. So oh, these are one set of exercises, simple traversals, and then we're going to do more traversals.